No, it's just totally new.
Oh, it is that bad.
Alright, so we are talking about tangent and velocity now. So our tangent problems. We have talked about like a tangent function. You know, in trig we have tangent. But we are talking now about something that is tangent to a curve. So when I say a line is tangent to a curve, that means it touches it. Okay, it has the same general direction as our curve at that particular point in contact. So for instance, if I were looking at this, okay, if I were going to draw a tangent line right here, my curve is decreasing, so my tangent line would be decreasing. Okay, you're looking for a line that basically hits the graph right here. Ooh, I can't draw straight up here. It's basically hitting at that point and bouncing off. Okay, so it touches right there at that point and bounces off. And this tangent line, it's not like the entire curve just has one tangent. Everywhere you're at on this curve would have a different tangent line. So if I'm up here, my tangent would look like this. If I were right here, what would my tangent line look like? I have a horizontal line. Now my graph is rising, so my tangent lines are going to be increasing. Okay, so any point on this curve would have a unique tangent line. And we're going to spend a lot of time talking about how do we find those lines and why are they important. Now all the lines I drew only hit the graph once. It is the case that if your graph, were to switch directions, maybe come back down, this tangent line would eventually hit the graph a second time, but it's far away from that point. So when the tangent only touches it once in the immediate vicinity. So right here, this is the tangent line. It may intersect the curve somewhere else far off, but in this area it's only hitting one time and bouncing. Alright, so if I wanted you to find the equation of the tangent line. Okay, finding the equation of a line sounds easy enough. We've done that before. How do you find the equation of a line? Yeah, y equals mx plus b. We need the slope and we need the y-intercept. Okay, we can get that if we have a point and a slope, right? I gave you a point. Did I give you the slope? y1. Okay, but that takes two separate ordered pairs. So all I know is that I have my parabola, and I'm trying to write the equation of the tangent line right here. And I know the point, but I do not know what would the slope of that line have to be right there. Why?
Because it intercepts the origin and the 1 point.
Why do you know it hits at origin? How do you know that the line I drew is perfect? I mean, the parabola hits there, but if you are just doing the line between these 2 points on your graph, that's actually called a secant line because it hits our parabola twice. We don't want that. We want the tangent line, one that's just going to hit that outside of the parabola and bounce off. So we have to figure out what our slope is. And we don't really know. So we're going to guess. Yes, but we are going to make an educated guess. We are smarter than just blindly guessing. What?
Or mold.
Okay. So Carson had this idea. What if we took these 2 points on our graph? Now, if I did the line between those, is that perfect for my tangent line? No. Is that somewhat close?
Yeah.
Okay. So if I were to do that, how would you get the slope between them? How do you find the slope between 2 points? Okay.
y2 minus y1 over x2 minus
Okay. So if my other point was xy, my slope y2 minus y1 over x2 minus x1. And I used the 1, 1 because the point I gave you was 1, 1. Okay? Let's make a table.
Let's make it big. That's
Alright. So what I'm going to do, go ahead and put in okay. Because we're talking about finding a lot of slopes. So the first thing person suggested is if x is 0. What would our y be? 0. And I'm getting my y from this formula. Y is equal to x squared. Okay, because it's a point on the parabola. So I'm taking 2 points on the parabola, finding the equation of the line between them. So if I did then my slope, I would have 0 minus 1 over 0 minus 1. So -1 over -1 is positive 1. Alright, but we've already agreed. Is that one perfect? How can I make it better?
slightly adjust the slope.
Okay, slightly adjust. So what if instead of making my x 0, I made my x 0.5? Okay, is the line here getting closer to my orange one? Yeah, as my x is getting closer to that 2, those lines are getting closer to that orange line that I need. So if my x was 0.5, all right, then my y, 0.5 squared would be 0.25. Okay, you can use your calculators at this point. We're just plugging these in to quickly get our slope. So I have parentheses 0.25 minus 1 over parentheses 0.5 minus 1. And my slope is 1.5. Okay, is that the best you can give me? How could I make it better?
Get smaller.
Okay, what should my x get closer to? 1. Because the point I'm interested in is at 1, 1. So if my x is getting closer to 1, my slope should be getting closer to the real slope. Alright, let's try 0.9. So if I do 0.9 squared, we get our 0.81. So now we do our slope. And we get a slope of 1.9. Alright, is 0.9 the closest we could have gotten to our slope? Alright, let's try.
Oh, is there a special thing that we could put 0.9 repeating?
Because that'd be really hard to find your y.
Oh,
So, now if I do my slope, y2 minus y1 over x2 minus x1. Okay. We can keep playing this game. Can I get closer to 1?
yeah.
Yeah.
Oh,
Is there a closest number to 1?
No.
Have we done enough that you think you could predict what this slope is?
Oh, yeah.
What do you think it would be? Looks like it's going to 2. Do we agree with that? And if we couldn't tell, we would need to put in some more x's. Now, we didn't put in anything bigger than 1. Could I have came in from this other direction instead?
Yeah.
Okay, let's try that and see if they go the same thing. So I'm going to repeat. But this time, let's try something bigger than 2. So what do you want to put in bigger than 2? 2.1. Alright, so then you have to do your 2.1 squared. Does everyone know why I'm squaring that?
For the y equals 6.
Yeah, just because the equation is y equals x squared. So I'm getting the point on my actual parabola. And then I'm using those 2 points as my slope. So y2 minus y1 over x2 minus x1. And I get a slope of 3.1.
Oh,
Okay. So what was wrong with that one? Yes. We wanted x to be close to 1 because my point was when x is 1. So 2.1 is still pretty far off. But there's no right or wrong answer for the numbers you plugged in. So there's no reason we couldn't plug in 2.1. But can I get closer to 1? Yes. So give me something closer to 1. All right, let's try 1.1 and 1.01. We'll test them. So if you put in 1.1, you have to get your y. And then we have to do our slope. And so we get the slope up. Have we done enough that you can predict what this slope is going to? Looks like it's going to 2, which is good news for us. This one went to 2, and this one went to 2. So we are pretty darn confident right now. The slope of that tangent line is 2. Okay, before I do anything else. Yes, what's your question?
How did we get here? So we plugged in numbers for x to get closer to the point that's given for the tangent line.
Yes, so my x's had to be getting closer to 1 because that was the point that was given. So we did numbers smaller than 1, so we are coming up from underneath. We did numbers bigger than 1. So I did 2 separate tables so we can kind of clearly see from each direction.
And so why did we plug it into the parabola?
Because we had to get the y value. We were looking at points on that parabola. So if you are traveling along this parabola coming in, what's your coordinate? So for whatever x I had, I took my x's, put them into this formula to find the y, and then I calculated the slope between that point and the point I was interested in. Right, so are there any other questions on how I got my x's, my y's, or my n's here? So all of this is because we really don't know how to find the slope of the tangent line, but we're trying to give it our best guess. Are we feeling pretty confident right now? Looks pretty good. And I asked you to write the equation. So now we know the point is 1, 1, and our slope is 2. So how do I write my equation from there? So y-intercept is -1. So y equals 2x minus 1. This is the tangent line at the point 1, 1. Now, is that the tangent line everywhere on this parabola? No. Every point on this parabola would have a different tangent line. But we found one of them. We think. We're fairly confident. Okay. So that was a little bit of work. What we just did is use a secant line to find our tangent line. So we said a tangent line only hits it once. A secant line is just any line that intersects a curve more than once. And so what we did is basically took a bunch of different secant lines, getting closer to the one we were interested in, and estimate our slope from there. And we had to do a lot of them. It's not like it can only plug in one point because if I just put in one thing and got 1.99, I can't know for certain that that's going to 2. But when I see, okay, my slopes are going up, was it 1.9, 1.99, now I can see it's starting to approach a single number. This is kind of an idea that's called a limit as well. And we will be talking about those a lot, probably Friday. We'll get into that more. So it's just talking about what number we're getting close to.
Or in the freaking apple.
Huh?
Spotted
Oh, yeah. So we say that our slope of the tangent line is the limit of the slopes of the secant line. So the way that's written, LIM stands for limit. I'm going to say as Q approaches P, Q being any other point on this line, so this was like our ordered pair Q, approaching point P. So as those 2 points were getting closer to one another, the limit of our slope between them was equal to N. Okay, so we'll see this notation a lot more, so if it's a little confusing right now, don't freak out. But limit stands for limit as my 2 points were growing to getting closer to one another. The slopes between those points was approaching the slope of our tangent line. The next slide, I just kind of put a visual of what this is saying. So this is 2 points on our parabola. So we took point Q, point P. Okay, and then we see Q is slowly approaching P. And what's happening to those blue and pink lines as those points get closer together? The lines are starting to get closer to one another. And we did it from both sides. We did when Q was bigger, and we did it when Q was smaller. And as Q and P get closer to one another, the slopes of those lines get closer to one another as well. So let's try another one. Approximate the slope of the line tangent to y equals negative x cubed plus 2 at the point x equals 0 by making a table of values for the slope of the secant line. Then write the equation of the tangent line. Okay, how many tables am I actually going to have to make? We're always going to actually do 2, 1 for each side. So I'm approaching 0. So I'm going to need one table where my x's are smaller than 0, and one table where my x's are bigger than 0. And the reason we have to check both, probably not yet, because we have nice equations for now, but eventually we'll see it's possible that those could be 2 different numbers. So if we're going to give one answer, we have to make sure they do match up. All right, so the x we're concerned about is at 0. So first table, give me things smaller than 0. So negative 0.5. And then if you were going to get closer, what would you have to put in? Negative 0.1, one more, negative 0.01. So my rule is going to be 2 tables with a minimum of 3 points in each. Now, if your points are too far away, you might have to pick more than 3, so that's okay. But that's our minimum. So then if I wanted points bigger than 0, what might I do? Okay. The point that I'm finding the slope between, when x is 0, what is my y? It's 2, because y is the opposite of x cubed plus 2. So the point on the actual graph is 0, 2. Okay, so if I'm finding slope between xy and 0, 2, my slope will be y minus 2 over x minus 0, which is just x. Okay, so that's how I'm going to find the slope. How will I get all of my y values? I have to plug them into the equation. So if x is negative 0.5, I have the opposite of negative 0.5 to the third plus 2. Does everybody do these calculations with me here so we know if anyone's having trouble? Alright, and then our slope, y2 minus y1 over x2 minus x1, or 2.125 minus 2 over negative 0.5, and we get negative 0.25. So now if I do my negative 0.1, so I have the opposite of negative 0.1 cubed plus 2, so 2.001. Now if I do my slope, we're doing the slope between the ordered pair 0, 2, and this one. So y2 minus y1 over x2 minus x1. And what did you guys get for your slope this time? And then if we do the last one, try not to round too much on these. If you try to round everything to 2 decimal places, your calculations are going to get really far off. Okay, it's a little tedious, but it's just a few numbers, so we can keep some decimals for a while. Do you guys feel like you can predict what this side is going to? What do you think it is?
0.
Okay, let's check the other one. So if I put in a positive 0.5, so first you have to plug it into the equation to get your y. So then you do 1.875 minus 2 over x minus 0, 0.5 minus 0. No, not always. It totally depends on the x's you pick and the function itself. So there is no guarantee that these m's are going to turn out identical. It just worked that way on this problem. Mainly because we are centered around 0, and if you think about x cubed, it's got some symmetry to it. So what's this side approaching? 0. So what is the slope of the tangent line? Slope of the tangent line is 0. And then I asked for the equation. So we have our point 0, 2, our slope is 0. So if you plug into y equals mx plus b, your y-intercept is 2. Equation y equals 2 is just a horizontal line. Our slope is 0. Okay. Any questions on that? Do we want to do one more today? Or we want to stop and pick it up tomorrow? We want to stop for today? Okay, so tomorrow we will pick up dealing more specifically with velocities.